also putting in an ultra low latency network and make it all connected, right? And I called that network back then the closing the data cycle network. So apparently it was picked up by NSF, the US funding body. But then a nicer term came along, which was coined by my friend Gerhard Fettweis and his colleagues, the tactile internet. Even though the vision I had originally goes well beyond the tactile internet, I'd love to stick to this term because that is really what we want to do. We want to transmit touch, right? So wouldn't it be great if our best, engineers could serve as a car or an airplane remotely, somewhere in the world? If our best surgeons could do essentially an operation in Sierra Leone? If you could shop online on Amazon and feel what you're buying in real time? If somebody could teach me how to paint, or I teach somebody how to play the piano? So what we're doing is we really want to build what I call the Internet of Skills. And to build an Internet of Skills, you need a tactile internet, right? So the underlying 5G and wired networking capabilities. And here's a problem. In contrast to the video transmission, which we have currently with the internet, the transmission of touch involves the transmission of an action and the transmission of a reaction, right? And if the reaction does not come within 1 millisecond, people start to feel dizzy. So we are hardwired for millions of years to essentially get millisecond response to any action, okay? So let me put 1 millisecond in perspective. 1 millisecond under ideal conditions, speed of light, buys you about 300 kilometers of range. That means 150 to go and 150 to come back, okay? Now in optical fiber, where actually all the comms happen, that's 30% less. And once you go to a real networking equipment with real application layer on top, that is 80% less. So how do you build a global internet, okay, this global Internet of Skills, or the tactile internet, actually using something which just works over maybe a dozen kilometers? Well, the answer is here, right? That's what we do. Breaking the laws of physics. Now we can't do that, so I'm joking. I'll go on. I'll show you what we actually do. So from an engineering point of view, this is what we do. You see on the left-hand side a teleoperator. Could be one teleoperator, could be several of them. Could be a surgeon, could be a set of surgeons. They are remotely controlling a teleoperator slave robot on the right-hand side, and they do that through a network. So it would be first a wireless network to enable scalability, and then that goes into a wired network, the internet, and then connects back into my wireless network, right? So we need to have the bilateral control of haptic feedback happening very, very quickly. So clearly we need an ultra-fast network. Whether we like it or not, we need to come up with totally innovative low latency networking paradigms. We also need to come up with haptic edge encoders, because that would allow us to scale essentially the technology at the edge. And we need some edge intelligence. So I call it edge AI. That edge AI would allow me to essentially predict my next movement. If I'm able to predict my degrees of freedom, whether that is kinesthetic or haptic information or tactile information, then I can buy maybe just a few dozens of milliseconds, maybe 50 or 100 milliseconds, which allows me to transmit the information around the planet. And that's what we're working on as part of this Ericsson lab. We have built here the 5G tactile internet lab, which allows me a real-time haptic feedback control using a very intelligent mixture of ultra-fast networks, haptic encoders, and edge artificial intelligence, right? And that is really happening right now. There are loads of really interesting research challenges here to make that happen. Now I want to discuss a little bit what happens once we have actually rolled this out, this tactile internet, and we have enabled this internet of skills, what's the impact on the global energy balance? And I think that's very pertinent to this conference, the GreenCon conference, really. And I don't want to look at it from an ICT perspective. So I don't want to dive now into the details and saying, you know, to roll this out, I need X megajoule of energy to get it going. I'd rather look at it from a different point of view. I'd like to understand how much energy does the planet actually use to do things today, okay? And how much of that energy could be saved by enabling essentially a remote skill set transmission, okay? So it turns out if you dive into the numbers, each of us on average in the more developed world uses about 195 kilowatt hours per day. Okay, that's 195 kilowatt hours per day which we are using. Now it turns out that on average, out of this, 70 kilowatt hours are to enable transplacement. So that means me going to work, me traveling to a customer, me doing some servicing, me flying somewhere on the other side of the planet to do something. So that's essentially 70 kilowatt per hour, okay? Sorry, I need to switch that off. And that is about almost 40% of the entire budget of my energy budget, right? So 30 kilowatt hours is air travel, and 40 kilowatt hours is car travel, right? So to put this in perspective, if you take a single transatlantic flight, you could essentially stop saving energy in that year, because essentially your transatlantic flight has eaten almost all your year's energy budget. So this is how serious it is to enable transplacement of skill. Now, if we could save at least part, let's say half of the 70 kilowatt hours I'm using for transplacement, 35 kilowatt hours, I could bring my 195 down to maybe 150, 160 kilowatt hours, okay, per day. And that is very interesting, because if you do another calculus where you try to figure out what is the renewable energy this planet can offer in average per citizen, it turns out no matter how hard we try, the upper bound is 180 kilowatt hours, okay? So 180 kilowatt hours is what this planet can offer in renewable. That's wind, solar, tidal waves, heat energy from the earth, etc. So that's the best we can do. And if we stay at 195 kilowatt hours per day use, we can never go sustainable. It's just not possible with our current energy consumption. So this tactile internet, this internet of skills, if it saves us to go on the other side of the planet to execute certain skill, then we could save probably an amount of energy which would allow us to truly go sustainable. So that's a really interesting balance where the tactile internet essentially plays a judging part or the balance part to bring the energy budget right. So therefore that's a very exciting development to make essentially this planet more sustainable. Okay, so let's move on now. After the high-level introduction, the big question is, how do you make that happen really? How do you really enable now this network? So clearly we need a new tech thinking. So that's really what we need. So we need a new way of getting things really designed. So one of the things we really need to watch out for is not only the low delay, but it's also the high reliability. So let's talk first about the high reliability, and then we talk about the low delay. I'll give you some ideas, but you're most welcome to get inspired with that and do other things, right? So in terms of reliability, what we're currently pioneering is this concept of decoupled up and down link. So currently when you use your mobile phone, the association of this mobile phone to a base station is based on the downlink. And once you associate it, the uplink will go for the very same base station. Now it turns out if you decouple that, so if you allow a downlink to come from one base station and the uplink to go to another base station, then you get a reliability improve of 2 orders of magnitude, right? So this is like from going from 2 nines after the zero, after the comma, to 4 nines after the comma. That's essentially what's happening there. And so therefore we're working on this, and that requires some fundamental changes how we design the architecture. But just such a small tweak allows you essentially to greatly improve the reliability. Now let's talk about the delay. So the delay is a major issue on the air interface already, so people work on that. They're coming up with new modulation schemes. They come up with new encoding methods which allow low delay encoding. They come up with new frames, MAC frames essentially, radio resource management frames, and 3GPP. The TTIs are being shortened from 10 millisecond down to below millisecond. So that's all happening. But there's something more serious here, and that's how the whole cellular network is constructed. So imagine I'm doing a surgery in Scotland, okay? So imagine a patient being in Edinburgh, in one of the cities, and there's a very good surgeon maybe in Glasgow. So, and imagine the surgeon is using an ABB device, an ABB Phantom device, which works on Vodafone, and the Edinburgh patient uses a Siemens machine which works on an O2 data plan. So they can't talk directly, actually, unfortunately. So what needs to happen is that, you know, my packet travels through the entire Vodafone network, out into the serving gateway, then the packet gateway goes out of the network, goes into the other operator's packet gateway, and goes all the way to the actual edge where it's being executed. Now, it turns out that the distance between your base station and the packet gateway can often be thousands of kilometers. So it's a long distance radius. And as we did the calculus before in terms of speed of light, you understand that the delay we get will be well beyond a millisecond. So if we want to have millisecond end-to-end delays in the network, we need to get rid of the core network. And not the core functionalities, but the actual infrastructure, okay? So we want to keep really interesting parts like the billing functionality, the authentication, the handover procedures, etc., mobility management. So that's all very interesting. But we need to get rid of this actual core network. So I've given you two ideas what people need to work on to really make that happen, right? So we need to totally change the way how we think about technology. Another thing we need to change is how we go about standards, because no matter what people tell you, 3GPP will always take about 10 years to get the technology out. And this is not a criticism, because 3GPP is very big, okay? And we need to agree, really, everybody needs to agree. Handset manufacturers, base station manufacturers, hardware, software, antenna, billing, authentication, security, whatever. You name it. So everybody has to agree, and that takes time. That takes exactly those 10 years we always take. Now, 3GPP therefore has developed in something what I call an iceberg, right? So it's very sturdy, it's very stable, it is really reliable, it's always there, but you can't innovate in that, and you can't accelerate innovation. So what we need is a transformation into a world which I call the Pandora world of standards, where essentially small islands are being standardized, and these islands communicate via really well-defined APIs. Okay, so because in fact cellular is the only community which is still working as a global standards body. You don't see Facebook, Cisco, and Intel sitting together and designing the next internet. You can't think about it. They have totally decoupled. So we need to do something very similar in the standards bodies. And I think people are waking up to that idea. So Etsy is doing quite a lot of efforts there. So Adrian Grace, who is the CTO of Etsy, is pioneering new ways of doing standardization. It's very experimental. We don't know whether it will work, but it is the right way in the right direction. Okay? Now what else? Business models will flip. They will definitely flip, right? So there are massive changes now coming with essentially a machine age being invoked, where literally machines now start to communicate. What we see is there's two big changes. The first change is that the vendors, the telecom vendors, like the Ericssons and the Nokias and the Huaweis, they're getting into the space of the telecom operators, okay, like the Vodafones, Verizons, like the Deutsche Telekoms. And the telecom operators are getting into the space of the over-the-top content providers. okay, like Netflix or anybody else. And that's very good. And why is that happening? It's happening because once we start connecting machines, we don't talk anymore to consumers. So we lose this element of B2C, so business to consumer. We have a very strong B2B, so business to business development here, and that essentially links up to companies like Ericsson. Ericsson has a very strong ecosystem connecting with B2B companies. So they would go to, for instance, a car manufacturer, Volvo, okay? They would go to a construction company like Skanska. And the two CEOs would talk and would say, look, I'm Ericsson, I'm able to connect all your cars, I'm able to connect all your construction sensors and safety stuff and actuators and robots and drones and you name it. And they strike a deal. And once the Ericsson equipment is installed, then, of course, Ericsson is in the really privileged position to procure an operator, right? So they would go for the cheapest operator which is available. So suddenly, whilst the operators in the past were very strong and they would procure the strongest or the best deal on the vendor side, it is the vendor which is in a very strong position, is procuring the best operators. So that's happening. And we see in the B2C and B2B world now this interlinking of these two worlds, giving it a lot of stability, so it's a good thing. Now, on the content provisioning, you see people like Netflix trying to get very close to the consumer because they don't want to stream the film from the other side of the planet. So they want to have it as close as possible to the actual consumer who will watch it. And it turns out that operators own a lot of real estate where they could put all this cloud infrastructure. So therefore, the Vodafones and the Verizons and all these and the BTs are starting to lease essentially the over-the-top capabilities to the content provider, and therefore that gives an extra ability to for them to make some cash. So therefore, there are some huge shifts happening in the background without the consumers actually noticing that this is really happening. Now. Before the consumer, though, should say whether they really need it. Okay, do they really need this tactile internet? So this is what I like to do. I'm an entrepreneur as well, and what we do is we try to reach out to an ecosystem, to our potential customers before we start developing things. So what I did is I went into the streets of London and I started to interview people about the tactile internet. Okay, I asked them, would you use that actually? Would you use the tactile internet to do things and to use it in your daily lives? And I'm showing you a short video here, and the longer videos are available on my YouTube site. So have a look for yourself. The video will be played right now.
Sure what I need to do. I mean, I'd like to feed blogs, so there could be some possibilities about touching the feed, but not quite sure what I think.
I think it's a fantastic idea. In my industry, I work finance-wise, but the industry actually I work in media and TV post-production. I think it'd be absolutely fantastic. I really think it'd be better.
So, as a creator of video series Digital Futures, which focuses on tech for good, I tend to keep a really close eye on advances that have the capacity to impact our day-to-day lives. The tactile internet for me is certainly one of them. If we can see and hear things that aren't close by, why shouldn't we be able to feel them, right? To be able to use data networks to relay actual human touch would be surreal, and it's attainable. To me, I think the biggest reason to get excited about this is the potential for health and education. Then you've got the marrying of the two worlds of AI and the tactile internet. You could remotely control humanoid robots who would be performing surgery or other public services. It's the immersive nature of something like this that really lights my fire.
It will be so nice when you touch your dad when he's traveling, and then you can go through the computer and say hello and keep while with it.
So as you have heard, essentially, the tactile internet will probably will be used to solve some personal problems and bring peace and prosperity around the globe. I hope you enjoyed the talk, and I'm happy now to take some questions, which I think will be moderated by John. But I'm going to go through the questions right now, and I'm gonna start answering them. So give me some moment, please, and I'll take that on.
Good evening, everybody. That was the keynote presentation. Tactile Internet, fascinating, interesting. Let's find out if there are contributions, there are questions from some of us out there. Let's have them. I hope somebody can hear me. Okay, okay. So, are there contributions? Are there questions? Are there comments? Want to share your view? Yes, Prof, we got that. It's an interesting presentation on where internet is going. I mean, it's really fascinating. Thank you for that, Ma. Okay, while we are waiting for more contribution over there, let's have some of our own views. Yeah, also just hold on.
This is one of the most mind-blowing presentations I've seen in a long time. About 10 years ago, I happened to stumble on a presentation called Ultra-Realistic Communication, where you put your hand in thin air and you feel what you are seeing on the screen, using sensors, using feedback and things like that. And I think that is beginning to emerge now, because the sensors and the actuators that we're talking about are things that we can transform the way we live. My only fear is that, of course, with artificial intelligence, are we sure that the robots will not take over?
Thank you, sir. Engineer Olafemi Olaniyan, as a poser, is concerned whether robots are not going to be taking over everything eventually, going at this very rate. Prof is still saying, so we need to start thinking of efficiency in the way we do things at work, the way we use energy, the important message from this conference is greening the future. Greening the future. Yeah. For us in Nigeria, it is critical because we are presently relying on fossil fuels, and that's a very very, I don't want to use the word disturbing, but really it is disturbing. Everything we do here is is on fossil fuels.
Okay. So, what are the advances we have in Nigeria that internet?
The advices.
What are the products we can show or technologies we have on tactile internet existing?
You mentioned something about transportation substitution.
Okay.
Where instead of going there,
Okay.
As good as life.
the skills can be remotely delivered using tactile internet. I think we can start from the really basic services in Nigeria. For instance, if there were a way that a doctor, you could sit in front of your computer and the doctor could carry out the diagnosis on you, maybe for the basic ailments like malaria, etc. Be able to measure your temperature, everything. That means that you don't have to transport yourself to the hospital. And the transportation cost or the transportation energy that you consume, transporting yourself, the doctor himself doesn't have to transport himself. And then we start at least because I know the lady there mentioned that in education, healthcare, and then those are areas that you can start. Yes. And the thing about is getting organized and looking at ways of making some changes.
I also think that's concerning, learning. Probably a teacher and relating with students, disseminating information and knowledge. Even up to the point of probably even doing practicals, having labs via the internet, all of this kind of issue. And it makes learning a bit a lot more interesting, a lot more real and practical. And of course, in the process, you are saving, of course, also energy, moving around, gathering so many people together. Once they can log on from the buffer of their various probably homes or wherever, they are there. Everybody can take the notes for that day and receive it.
You gave the citing an example of what he was going through.
You just explain.
Do you work for Next or are you making an
Put down Samsung.
It's true now. Samsung phones are not energy efficient. Keep eating them. But we'll not mention that in the report, of course now. But we just say tactile internet allows us to have enhanced energy efficient phones, smartphones. In Nigeria, because of that, is driving physical appearance to the reduction of use when nothing there. Yes, that's demand side management. Okay, if, for instance, we're not in that side of the lights should go off automatically. I think the cat can go while we try to.
Engineer Tunde Saliu, can you hear me? Please, if you can hear me, type something on the screen. particularly because of your comments yesterday, Engineer Sadio. I guess you can hear me. Particularly because of your comment, and of course, by the reason of the time we agreed, everybody agreed for the meeting. We are thinking of officially rounding off very shortly, but of course, the interaction can go on thereafter. It's already 8 o'clock, 8:01 here now, 8:01 p.m. So, while we close here officially, maybe we'll just
Continue
continue
chatting.
with the interaction afterwards.
The session remains live.
Yeah, still live, everybody's still getting to hear from one another. From the laptop. Frank Electronics.
The last two joined us we were actually 20 online yesterday.
20, not
Not
18.
13.
Yes, Prof, thank you. We got our comment. Let's keep it going. Just like I said, we want to try to round off here now. Before we do that, online we still have Prof. That's Professor Gloria Chukwumedu, Triple Nigerian Section Chair, Engineer Azuka.
Consult chair.
Sorry?
Yazuka is the consult chair.
Okay, Engineer Azuka Consult Chair. Engineer Tulu Sali is there, Principal is there. Engineer Ade Soji Lawal. Uzo Matu is there. Then Jeffrey is also with us online. Here physically we have in the studio, in the live studio here, to my immediate far left, Engineer Olafemi Olani, just for the contribution. Then sitting next to him is Mr. Frank Electronics, here with us. Then Cynthia, she was here yesterday, she's here today as well. The row behind me, I have Okoyemi Ojedeji, sorry, Okoyemi. Shubomi is still here with us. He was here with us yesterday, he's still here with us. Of course, John Funshu Adebayo. And lastly, my humble self, Makinde is my name, Engineer Adekunle Samdi Makinde. So, I want to thank you, everybody, for your time. I also appreciate your patience and your contributions over there. We want to log off now. I mean, we want to round off the session now. But then the interaction continues. And before we go in the mood of the season, I want to wish everybody Merry Christmas and Happy New Year in advance.
Merry Christmas.
I guess you can see my Christmas card, and this card is particularly for you, everybody. Merry Christmas to you. I'm wishing you a prosperous 2016 as well.
Amen.
So, just like I said, the interaction can continue. Okay, it's okay. Okay, close on Principal, when am I getting the hard copy package of the gift? I'll be waiting.
Bye. You have to say bye. So let's play some music today. That one will take it. These are the five that
Now, really, I've always said it, and I'm still going to say it again. When you have an economy that is import driven, we import everything, we depend on the outside world for everything. We don't invest on research and development, unlike what some other people do. We're pretty, for a long time, we're still going to be looking, at a fast distance at what many other people are doing. We have research and research institutes and so on here, but they are more or less glorified classrooms and
Research institute.
yeah. So when you don't invest, when the economy is not investing and the nation is not investing in research and development,
Have you visited any research institutes recently?
what, there is a lot of inventions are happening there. A lot of innovations.
And today said we should send his own cap and
Oh yeah? Okay.
Paul said, okay, 1 million.
The thing about research is that it needs money.
I think that was Azuka, yeah? Yeah. Thanks, alright. See you guys another time. Back to work. It's 11 minutes here and we're here. Oh, that's a lot. Nigeria, I'm listening.
Okay.
You are
I
saying something.
was saying that research is money.
It's a lot of money.
The
A lot.
companies that are dominating in pharmaceuticals, IT, name it, they spend 10% of their budget. They spend 10% of their budget on research.
Even in some client.
The budget of Apple for research is more than Nigeria's budget.
Normal now, regular.
So that's why they keep turning out stuff.
Apple, I'm not talking of the US economy, the population. It spends more on research than the whole country,
Yes.
on everything, to provide everything.
So that's why even you won't even see such in the budget of most African countries.
Yes.
Even on science and technology and education, probably by 30–35% will be on defense.
Yes.
And you don't even get to see, of course, you see what is happening with the defense money.
Everybody is.
When a single individual is the finance minister, is also the central bank governor, is the accountant general. And it's just doling out of that.
And sharing the money.
I didn't know they were sharing the money like that.
I didn't know myself.
I knew they were sharing, but I never imagined that magnitude.
It's unimaginable.
I never ever imagined that magnitude.
Around applied somehow.
They give people 100 million dash.
Yes. Just like that.
675 million.
They'll give you 100 million dash.
What will you do with it?
You will not be able to spend it. You will not be able to spend it. You will not be able to spend it.
Oh,
Oh,
my.
really?
Serious.
By last week.
You won't be able to sleep again.
Serious. If you just destroy anybody that
You
connects,
will take your peace away.
forget that one.
I told you.
You will lose your sleep, you will
Forget.
lose your
I
peace.
told Mr. Frank that if Jonathan wins the election, I will
No, but
relocate to
it
Benin.
doesn't work that way.
If Jonathan is,
The
If he
more
won the election,
money, the more
I will relocate to
problems.
Benin.
That's the honest truth.
no, when I retrospect, honestly, I always thank God that God loves us in this country so much.
Yeah.
That He didn't allow that regime, that tenure to continue that way. I'm telling you, by now, I would have been running to Greece for bailout. Bros, can you give me $50,000? You know what Greece is going through? We would have been begging Greece for handouts. No. The country would have been completely prostrate under.
But what pains me most is that that woman,
Supposedly,
kept
crime.
saying to Nigeria,
The economy is.
that the economy
I mean, can't you see where Naira is now 260, I mean, dollar is 260. I mean, you traveling at this level now, then you are just going to waste.
$100 is 2,000 there. $100 is 6,000 there.
You are traveling now, you are just going to waste money.
Just Ethiopia
You
there.
can't compare Ethiopia with Nigeria because after the Ethiopian problem, there are serious farming problem and all that.
Yes.
They turned that country around.
Yes.
Today, Ethiopia is the fastest growing economy in Africa.
Yes. $1 is
Their
2 point
power,
something.
their power investment. In fact, investors that they are doing their first choice. Why did you just drop yourself?
Because the
They made
video was on.
Ethiopia their first choice investment gateway to Africa. You know that. And then all their dams, majority of their dams are hydro. So their energy cost is about the lowest in Africa. And they even export energy to their neighbors, Uganda and Kenya. That's Ethiopia that children were starving on the street
Haile Selassie.
and dying of hunger.
Emperor. Naruto.
That's what you talk about turnaround. To raise money for them.